Good afternoon, class. This is Mr. Holloway again. We're going to take a little bit of time and we're going to talk about electric fields. Okay? Got a new marker here, so let's see if we can get it up. Okay, there we go. So we're going to spend a little bit of time, and we already talked about in class that everything has an electric field. And it's fairly simple. Now, this is going to look familiar. We studied this back at the beginning of the year. Every electric field has a magnitude and a direction. So that right there tells me they're what? Well, they're obviously a vector quantity. Okay, so all the fields that come into it have a certain place and position that they go in. For instance, let's talk about if I have a negative charge, my line should, I'm going to go ahead and draw some lines here. My charges or my electric field flow into the negative charge in this direction. Okay, and this is called the negative, so they move toward the particle. Okay, so let's say I have a positive. Well, we know what these charges do. They're always opposite of each other. Positive charge, the fields flow away from the particle. Okay? They flow away from the particle. That's in all electric fields. They flow away from the particle in a positive particle. Okay? Negative, positive goes away. Negative goes towards the particle. Okay? Now there's also another thing called a line of force. And it's fairly simple. If I have a negative particle, they obviously go towards. And if I have a positive particle, they obviously go away. So that's the similarities there. So let's take a minute and look at the electric field equation. My electric field equation is E is equal to force over charge. Okay? So this E tells me the electric field. Obviously, this tells me the force involved, and this tells me the charge of the particle involved. This is how we go back and we find the electric field. Okay? So this is going to be measured. I know force is measured in newtons, and I know charge is measured in coulombs. So that gives me a newton per coulomb when I start talking about the electric field. Now, in a single charge, I also have my electric field going out. Now, pardon me here, my lines aren't very straight, okay? But there's going to be opposing lines on each side of the field. Now, let's think about back in middle school when we had a negative and charged particle, or let's say this is my north and south pole. It builds an electric field between the two, and there's going to be opposing forces on each one. Now, even when the forces come out of here, they'll go out and take a big long trip until they meet back over on the other side. Now remember, positive, they go away. Negative, they're going into. Okay, so that shows me the direction of the forces. Okay, positive going away, and then this force would come in this direction. Same thing when I have that force coming out. Okay, it's going, oops, wrong direction. It's going away from the positive and into the negative. So that's pretty much how electric field works. Anytime I have electricity involved, I have this field generating around that electricity or the electrical current. We'll stop on this part, and I'll get into a little bit more about charged plate and how batteries react to each other and how that electrical charge is created within a battery. We'll do that on the next video. See you soon.